All right. Oh, you're right. So, oh, this is not the right file. I'm not even the right folder. Try again. Could you guys please find worksheet 19B? We're not going to do your homework assignment for you, but that was a good thought to look at some questions off of 19B that weren't circled, and that way you had some parallel problems that you could think about. Like number 1. Abruzzo, there you are. Number 1. You know what? You know why it's confusing? Because it's got the stinking 0 in it. I hate those questions. All right, so once my file pulls up, I'll write down what number 1 is for our friends out there in the interweb. Where is Jacob? Jacob. Oh, well, assuming you're going to show up eventually, Jacob. We'll see you in a minute. Otherwise, oh my gosh, that's dramatic, man. All right, yeah, that was a rough semester for the poor kid. All right, so number 1 on the bookwork page, not circled, so you don't have to do it, but it's good warm-up for us today. It says arcsine 0. So this is asking you, and I like to rewrite them this way because my brain gets really confused on these. It says, where would your sine function be equal to 1? Or 0, not 1. So I think about my arcsine only being defined here to here. And where is sine value of 0 in that area? And it's right here, right? This is the ordered pair 1, 0. And I don't like this question because there's too many zeros in it and it's making me paranoid. But the answer is 0. If it freaks you out so much you need to label it, call it 0 radians.
But just writing 0?
0 is acceptable, yes. That question was really awful. I understand why you picked it. Let's look at one of the composition ones later on down the page. Let's take a look at... Well, 31's not that exciting. We're going to do some of those today. It looks exciting, doesn't it? Which one? Number who?
I said 31 because
31.
It was like the 2 over 9.
Oh, yeah. It's not bad. You just got to draw it. Because it's not a unit circle measurement, right? So it says cosine, arc cosine.
Oh, I got you.
Yeah, we're going to do quite a few of these today. So arc cosine is only defined here. Positive 2 over 9 indicates it would be in quadrant 1. Oops, that was kind of a triangle. Cosine ratio would be adjacent over hypotenuse. And then you could do a little Pythagorean theorem if you had to. But all I need is the cosine of that triangle. So the answer is 2 over 9. So it's really boring. Sorry, that wasn't as exciting as I thought it would be. You want to look at one of the composition ones that wasn't assigned, though? Like, 37's fun. 37 says sine. And then 2, random 2, times arc, cosine. Square root of 2 over 2. Okay, so composition, you always start on the inside in algebra and in PreCalc alike. And I answer this question first, and it says arc cosine. Where is cosine going to come out to square root of 2 over 2? And remember, cosine is only defined here to here. So at what radian value do you get a cosine of square root of 2 over 2? Positive. At pi over 4. Good. So this says 2 times pi over 4. What is the sine at that radian value? So this is now an old question, just with a little twist. 2 times pi over 4 is pi over 2. So this question really is saying, and this is what I kept asking you guys yesterday, is this an old question or a new question? That's an old question. This belongs on last week's test. What is the sine at pi over 2? And the answer to that is 1. How fun is that? So we're going to do a little bit more of that today. Could you find the next worksheet in your packet? It's worksheet 21. And today we're not going to use the little half unit circle. We're going to put that one away and only use our big unit circle because that's what you're going to do for me on the test on Friday. So this very first question on the notes is kind of like the one that Daniel asked about on the homework where it was a really weird ratio, not one that we saw in the unit circle. And this is another example of that. So you start on the inside and it's asking about arctan having a value of negative 3 over 4. Okay, think about that. Arctan is only defined here to here. So if it's producing a negative ratio value, which quadrant specifically are you in? Yeah, we're in quadrant 4. So I'm going to draw myself a little triangle who, and you can label the angle whatever you want, but I need my tangent ratio to be equivalent to negative 3 over 4. So be careful about signage here. This would have to be a -3, right? A downward movement. And then the adjacent leg would be a 4. And then this is a Pythagorean triple. It's a 3, 4, 5. But if you weren't sure, you could go through Pythagorean theorem and figure that out. The way you find the hypotenuse in a right triangle is use square root leg squared plus leg squared. Today I'm going to talk to you a little bit more about Pythagorean shortcuts. Besides the triples, we're going to have some really weird algebra Pythagorean theorem problems today. And while there's nothing wrong with setting up like long Pythagorean theorem, the formula, I know you guys have shortcuts in your brain somewhere. Like, hey, when I find the hypotenuse, I just square the legs, add them up, and square root them, which you can do in one step, right? If you're trying to find a leg, you have to square root the hypotenuse squared minus the leg squared. So all that manipulation of Pythagorean theorem that you smart people do in your head, we just got to focus on today. Because turns out that's the only tricky part of the lesson today, is Pythagorean theorem. Something that you've done for years and years. Hey, I didn't finish the question though. They don't want this. They want the cosine of this mystery angle. So cosine would be 4/5. Now notice I just got a positive ratio for cosine in the fourth quadrant. Does that make sense?
Yes.
Should be that way, right? All right. So next problem in your notes, and this is on your notes, I believe. This first one's a question from yesterday. Now, sine at pi/3. Is that a newish question or an old question? That's an old question. So just go to your unit circle and take a peek at pi/3. What is the sine value at pi/3? Okay. So this question really says arc cosine square root of 3/2. So essentially, for my brain, I got to write it this way. Where does your cosine come out to square root of 3/2? Now, thank you. You guys are very good at this, but one thing I got to remember, because I need this. Arc cosine can only look here and here. So I got to make sure if I'm looking for positive square root of 3/2, you're looking at the right place. And you told me it was at the radian measure of pi/3. Thank you. Oh, that's better, because pi/3 is wrong. And that's not what you told me. Sorry. I just ignore everything you said to me just now. So I'll give you the wrong answer, right? What if I tried to play it off like that was the teachable moment? Like, oh, yes, I made a mistake on purpose. No, that was just me. All right, so this one. This is not a unit circle, friend. This is a draw it yourself kind of a problem. So arctan, only defined here and here. Since I have a positive ratio, where should I be? Up in quadrant 1. Good. Now, I always mess this one up, so hold on. You know me and tangent. Tangent, opposite over adjacent. This is a 5. This is a 12. If you know off the top of your head this is a Pythagorean triple, you know it's a 13. Otherwise, you could set yourself up a little Pythagorean theorem. To find the hypotenuse, you square the legs, add them up, and square root the sum. Yep. So now we got to answer the question. So sine. What's the sine ratio here? 5/13. Got a positive sine ratio in the first quadrant. Looking good. All right, so remember your unit circle is available to you, and at the bottom of your unit circle, you got this information. So if you're really in a jam and you're like, oh my gosh, I need my color, like marker colored unit circle. No, you don't, because everything you need is staring right at you. See how it says sine goes from -pi/2 to pi/2. Cosine will be from 0 to pi. And then stupid tangent, -pi/2 to pi/2, but with parentheses instead of brackets, because we learned yesterday that you can't work with the tangent at the quadrantals because it's undefined and then it's not possible, and it's a bane of my existence. I hate that question. All right. You do get your unit circle. So, yay. This is what we're going to do today. This first question looks really unusual, but once we do a couple of them, you're going to be like, this is fine. So, the original question, I'm hiding it, says, what is the tangent? So it's a composition question. So tangent arcsine of alpha is the alpha symbol, but an A is fine. You start on the inside, just like with every composition question, and you would write it up as, and they use U instead of theta, which I think is kind of weird, but whatever. So they said the sine comes out to A. Let's call it A for a moment. Sine's a ratio, people. How can you rewrite A so it's a ratio? Yeah, boom, ratio. Like, that's not wrong to do, but now it's a ratio. So what that means is I could take a picture of a triangle that I will draw in the proper quadrant, and I could label the legs of the triangle in accordance to the sine ratio. So sine, remember, is opposite over hypotenuse. I'm going to use little kid formulas today because they're a little more friendly today. I don't want to use x's and y's and r's because they throw x's and y's and r's in the middle of the problem, not meaning x and y and r. It drives me crazy. Anywho, this triangle is labeled for you already. See how the opposite leg is a, the hypotenuse is labeled as a 1, and after some smooth Pythagorean theorem, y'all could find this missing horizontal leg. So, the shortcut for finding a leg of a right triangle in Pythagorean theorem would be to square root the hypotenuse squared minus the leg squared, the one you know. But of course you can go back and do Pythagorean theorem the way you've always done it. I just want to know that people who are using a shortcut, they're using it properly. So here's what we're going to do. You're going to take your hypotenuse squared, that's 1 squared, and then you're going to subtract the leg you know squared. Now the only thing I expect you to simplify here, guys, is the 1. 1 squared is 1. Now, the other thing I need you to work against, sometimes kids look at that leg and they see the square root and they see the 1 and they see the a squared and they think they're supposed to square root the pieces. That's not how radicals work. You cannot separate a subtraction problem into 2 separate radicals. This is simplified. Don't touch it. The only simplifying you do here is 1 squared is really a 1. That's it. Okay? So now they want, think back to the problem, they wanted the tangent ratio. So we would set up opposite over adjacent, and it would start like this. And then we go, oh great, math doesn't like that. So they would rationalize by hitting the top and bottom, the numerator and denominator, by the square root. So up in the numerator, it's just a times the icky square root. And then down in the denominator, when you multiply a square root by a twin square root, you're just squaring it, and you're canceling out the square root. So that answer looks disgusting, but that's it. Just some weird manipulation. I'm sure you've noticed this in math by now. The more general the problem, like the more variables, the ickier the work looks. Unfortunately, that's kind of the direction we're leading in our big kid math. They like to have general problems. All right, so let's take a look at this one. This one's not done for you. So you start on the inside, and you think about this question. It says arc cosine x. So this is essentially asking you, the cosine ratio comes out to an x. I need y'all to write that as a ratio. X over 1. So now I think about arc cosine, and because it's positive, all of our work today in this section is going to be located in the first quadrant. We're going to assume that all of the variables are positive, so just you're always in the first quadrant for these questions. That's not straight. Okay. All right. So label your legs. Your adjacent over hypotenuse formula, little kid formula, but that's okay. So our adjacent leg is x, and our hypotenuse is a 1. They're going to want me to find this missing vertical leg of my right triangle. So the shortcut with Pythagorean theorem would be that you square root the hypotenuse squared minus the leg squared when you're finding an additional leg. So for us, that would be the square root of 1 squared minus x squared, better known as 1 minus x squared square rooted. Yeah. Do not simplify that. That is simplified. So now they want the sine of that angle. So I like thetas. I don't know what they have against thetas. So the sine of that angle would be, let's see, opposite, that icky thing we just found, over hypotenuse, which is 1. Do I have to write that? No, but I'm not going to erase it because I'm lazy. There we go. Ta-da! Now the next question we do, you're going to find it a little boring because the triangle we create is going to look kind of the same. So when we move on to the next 2 questions, I'm going to change the problems a little bit so we get some variety in our life, and you'll see, like, I guess the most difficult the question could possibly be. It's not difficult. All right, so this question, 8b, start on the inside. The clue they give you, arc sine x. So that means your sine ratio is x over 1. Alrighty, here we go. So we're in the first quadrant. Create your triangle. Sine, remember, opposite over hypotenuse. And take a wild guess what that missing leg's going to be. Yeah, because we have the same like values for the leg and the hypotenuse, that other leg is not going to change. It's just going to be in a different position on the triangle. But just for my notes, I'm going to write down this. So this missing leg becomes, Adam told me, square root of 1 minus x squared. So now I go back to the actual question. Oh, my Nemesis, cotangent. What's cotangent? Yeah, you're giving me the answer. I was just looking for the formula. Adjacent over opposite. So adjacent over opposite would be the square root of 1 minus x squared over x. Now, do me a favor. Next time we test this, which will be Friday, write down what you're thinking. So, like, if you think cotangent is opposite over adjacent, and that's the mistake you've created, just, I need to see that. Because on the questions for 4.3 on the last test, I was just getting wrong answers from kids. And because nothing else was written down, like, I just assume you don't know what you're doing. But I think in some cases it was as basic as, like, you had the wrong ordered pair. And I didn't know that because you didn't write down what ordered pair you used. You didn't show any work. So just the more you write down, it's just communication for your teacher. And, you know, worst case scenario is, now I really know what you did wrong. But the best case scenario is I can give you a little better score than I normally would have. Okay? So we're on the back, and we're going to change these two questions. So if you're working ahead of me, stop. I'm going to change this question to say x over 2. I'm going to change this question to say x over 3. Get really crazy. Wow. So we start on the inside, and you have to draw me a triangle who has the ratio for cosine as being x over 2. So first quadrant, x being the adjacent leg and the hypotenuse being a 2. So again, I need to do some calculation, Pythagorean theorem, to find this missing leg. So a little note to self here, the way you find a missing leg in Pythagorean theorem, the shortcut is you take the square root of the hypotenuse squared, and then you subtract the leg squared. So, the hypotenuse squared minus the leg squared, the only thing I expect you to simplify is that you call 2 squared a 4. So this is the square root of 4 minus x squared. And then I go back to the actual question. What do they want from me? They want sine. So Adam already answered that for me. He said it's the opposite leg, the guy you just found, over the hypotenuse. No simplifying necessary. That's where kids get into trouble on this question. They either do Pythagorean theorem wrong, or they try to simplify things that are non-simplifiable. That's not a word. I don't know what the right word is, but it's not that. All right, and then number 2, we changed the question to say x over 3, but it's going to work the same way. So we're in our first quadrant. You're going to draw me a triangle whose sine ratio is x over 3. So sine would be a vertical leg. Oh, see, this is what I don't like. They use x and it's vertical and it confuses me. All right, so this mystery leg is x and this hypotenuse is a 3. So again, you're going to do a little Pythagorean theorem to figure out this missing leg. I'm going to use the shortcut. So that would be the hypotenuse squared minus the leg squared. So that would come out to, instead of 3 squared, call it a 9. So square root of 9 minus x squared. Beautiful. And then what do they want from me? They want tangent. Oh, for Pete's sake. All right. Tangent would be x over that. And then, of course, we can't leave our answer like that because someone decided that's not proper. So I'm going to come through and I'm going to multiply both the numerator and the denominator by this disgusting radical. And up top, you don't need to do any work, guys. There's no simplifying here. In the denominator, the only thing I need from you is that you understand when you multiply identical radicals together, square roots, it's the same thing as squaring them. So you end up with just the quantity 9 minus x squared. There's absolutely no simplification on this answer. Don't try. I know it feels like things cancel, but nothing cancels. No. Yeah. That's I don't know how to say that 20 ways until someone believes me. There's no simplifying here. Okay? And that's it. That's my whole lesson. These questions here, I'm going to stop the video for a moment while you're going to independently work on these. I'm going to freeze the screen, and then I'll start up the video with the answers, so internet, you don't have to wait long. But we're going to try these independently, okay? These are the answers. All right, homework is on worksheet 22.